we will be anonymizing the chat and trying to avoid saying your names during the session, so it will be fully anonymous. And the session today is due to end at 11:45, so I'll try to get through it in 40 minutes, but we might go a couple of minutes over because obviously I've been a little bit late. And please accept my apologies for that. It's been a bit of a nightmare today. Okay, so what are we going to cover today? I'm going to give you a brief overview of what research data management is. We're going to have a look at a data lifecycle. We're going to think about policies for research data management, storing and organising data, and then we'll have some time at the end for some questions. Okay, so what is research data management? Often we call research data management RDM, as another lovely OU acronym. So if you hear me saying RDM, that's what I mean research data management. So RDM concerns the organisation of data from its entry to the research cycle through to the dissemination and archiving of valuable results. It aims to ensure reliable verification of results and permits new and innovative research built on existing information. So this is a quotation from the Digital Curation Centre. The Digital Curation Centre are the leading experts in the UK on research data management, and they were really helpful when we set up our RDM service at the OU. And if you have any sort of generic questions about research data management, their website is a really good place to look. So, research data management covers the management of data throughout your research lifecycle, more on that in a bit, and beyond, when you will be sharing your data with other researchers. This is relevant to all research which produces data, although you might find that the methods that you use differ depending on your type of research or your academic discipline. So depending on your methods for data collection or the type of data that you're working with, your way of managing data might be slightly different. But in essence, it means looking after your data during your project and after your project. But if you remember nothing else, remember that research data management is there to help you do your research. It's not supposed to be an extra administrative task that someone's forcing you to do. Research data management ultimately means that your research will be of a higher quality. So there are loads of different research data lifecycle models, but this one from the UK Data Archive is the one that I favour. The UK Data Archive is funded by the ESRC, so the Economic, Social and Research Council. But I think that the guidance that they have on their website and this lifecycle model actually are applicable for all types of research data, regardless of which discipline you're working in. So when you're thinking about how you're going to manage your research data, you should think about which actions are required on your data at each of these points in this life cycle. For example, at the creating data stage, you'll need to be thinking about writing a data management plan, gaining consent to share data, finding pre-existing data, as well as the collection and creation of data and metadata. I'll talk a little bit about metadata later, but it essentially just means how we describe data. So thinking about this in advance will ensure that your data is in a really good position to be worked with and to be shared at the end of your project. Processing data stage, the second stage in the life cycle, will often involve data entry, transcription and anonymization, as well as quality control. And you should also be thinking about how you're going to store the data. So where is the most secure and sensible place to store your data for your project? And I'll be talking about data storage in a moment as well. The analysis phase is what many people think of as proper research. So this is the time when you'll be looking at your data and finding conclusions from it. And during this stage, you'll be really thankful for the fact that you've managed your data well up to this point, as analysis will be much easier if your data is organised beautifully with excellent keywords and metadata assigned to it, so that you can really understand what your data is, how you collected it, and find those important links between different items of data. The next step in the life cycle is the preservation phase. And this involves assigning metadata and migrating formats for archive. Now, much of the work that you need to do to preserve your data can be done in advance. So when you collect your data, you could already be putting it into the formats that are needed for preservation. And so you can save time at this stage by getting ahead and doing it earlier on. And that's why your data management plan is so important, because it helps you to think about ultimately what you'll be doing with that data at the end of your project and what actions are needed on it in order to do that. Now, by putting your data into a trusted repository or archive, you will need to be providing access. You will be providing access. So that's the next section, giving access to data. You also need to think about assigning licenses. And we do talk about licenses and data sharing in another webinar, which is coming up in probably in December. I can't remember what date it is, but I will send out the link to all of our whole calendar after this session. And then the final stage is reusing data. So it might be you who reuses your own data for a new project, or it might be someone else. And this reuse of data might be for further research, or it might just be to validate results. So to make sure that the results in your publications stand up to the data. Or it could be for teaching or for journalism purposes. So there's loads of ways that data can be reused. And when we think about managing data, we're really thinking about it with the end goal of it being in a good position to be reused and to be preserved at the end of your project. So everything that you do at the beginning of your project really is put in place in order to make sure that that data is really high quality data that can be reused and that you can give access to people to scrutinize it and to do what they need to do with it. So this sounds like it's going to be very time consuming, and it does require an investment of effort, but ultimately it's something that can actually help save you time because it will mean that you're working more efficiently. Now, many of us are well acquainted with the frustration of trying to track down a fact or a document we know we have somewhere, or trawling through multiple versions of documents to find the final copy. But good research data management, so setting up an organizational system that works for you and ensuring that everything is properly filed and labeled to enable re-identification and retrieval, that can make life so much easier for you while you're doing your research. But it's not just a matter of saving time and reducing unnecessary effort, although that's clearly a major benefit for you. Having everything well ordered can also help you to get a better feel of the shape and the scope of your research material, which in turn can enable you to spot patterns or connections that might otherwise have been missed. It's also really well worth doing because the data that you're producing or working with is very valuable. You're likely to have been offered funding in order to collect this data, or you might be doing your PhD. And the amount of time that you spend collecting data means that that data is really, really precious. The amount of effort that you put into it to then store it in a haphazard way with no real thought about how it's being looked after seems to me like a waste of time and money. And as well as all this being true for your own research, your data might ultimately be of use to other researchers. So having everything well organised and properly labelled also has the potential to save you a lot of time at the end of a research project when it comes to deciding what to do with your data. But we'll talk a bit more about that later. And finally, a real key driver for doing this is to meet your funder and institutional requirements. Now, we'll just have a quick look at the requirements. So first of all, the OU's RDM policy. So this actually is being refreshed at the moment, and there'll be a couple of new things added to it in the next couple of months. But the general gist of it stays the same. So your data should be made open wherever possible, including physical data, no later than the first date of online publication of research. Published research data papers must include statements on how and what terms supporting data may be accessed, or if there's no data, the paper should make that clear. Your data must be managed responsibly throughout your project. The university will provide services and facilities, so training, support and guidance. So obviously you found this training, so that's one of the things that the university offers. But we also have a website with a wealth of advice on it, and we've got a repository that you can use to publish your research data. It's important to remember that all those engaged in research at the OU, including those involved in collaborating with other institutions, must take personal responsibility for managing their research data in accordance with the university and funder requirements. I do talk here, and I will talk a little bit later quite briefly about data sharing. It's something that I'm going to mention quite a lot because that's the ultimate aim of this whole thing, is sharing your data with the public. But as I've mentioned, we're doing another webinar on that in a few weeks, so keep your eye out for that one. And what do funders expect? So these quotations are from the Concordat on open research data, which was developed by a UK multi-stakeholder group, including UKRI, or actually on here it says Research Councils UK, but it's UKRI now, the Wellcome Trust and HEFKI. So good data management is fundamental to all stages of the research process and should be established at the outset. Open access to research data is an enabler of high quality research, a facilitator of innovation, and safeguards good research practice. So I think the key thing here is that research data management is now considered to be a really important part of research. Good research requires good research data management. That's the thing to note. And as I mentioned, we've got our website, which is linked to here. We've got an inbox, library-research-support. So if you email that inbox with any inquiries, we'll get back to you. And we have our training program, which this is part of. So there's loads of support available to you at the OU, and hopefully we'll be able to help you with anything that you need throughout your project in order to make sure that your data is being managed properly. And we also have a repository, which I mentioned before, called Ordo, which is a secure repository for the long-term storage of data. It meets funder requirements, and it enables you to share your data and gain a DIY from that data. So the key thing to all of this is that you should start as you mean to go on. Consider all the preparation necessary for making your data shareable and how you can reduce the workload at the end of the project by doing work during the project. If you're on a funded research project, you'll know that your funding is only applicable until the end of the grant. So if you haven't set aside the time during your project to convert your files into formats for preservation, for example, or to assign metadata, you're going to be in trouble when that funding runs out at the end of your project and you don't have any time or money in order to be able to get it into a repository. So it's really important that this is something that you consider right at the very beginning. You might have heard about data management plans. That's a document that you can write down your plans in at the start of your project. Many funders require them as part of a grant bid. We had a webinar on this a few weeks ago, and if you missed it, we did record it, and I can share the link with you if you'd like it. So just pop me an email and I'll share it with you after this session. Okay, so in terms of storage and security, it's really important that you ensure that you have a consistent approach to storage and backup, which is agreed amongst your team if you have one, so that everyone is accessing the same data and uploading it in a consistent manner. The preferred option for data storage at the OU is networked file storage, as this is secure and it provides guaranteed backup. But if you're working in a team, SharePoint will help you to manage your data effectively, and you can have a team site on SharePoint that makes it really easy to control versions and tag different types of documents and to create folders. So it's really great in terms of data management. But if you're working with external collaborators, using SharePoint can be a little bit tricky because they will need to get visitor access and get an OU computer username. Whereas OneDrive is secure, it has many of the same functionalities as SharePoint, and it can be accessed by anyone with a Microsoft account inside or outside of the OU. So it's much easier to get external collaborators set up on it. All data on OneDrive and on SharePoint is stored within the EU, so it's GDPR compliant at the moment. Then we've got Ordo, which is our data repository. It's really easy to use during projects, but it doesn't offer online editing or version control. So it's not ideal if you're working in a big team with lots of versions of the same document. I would really opt for SharePoint or OneDrive. I've also got on here the STEM Specialist Support Unit. If you're a STEM researcher, you will have access to STEM servers which have similar kind of functionality to OU Network's file storage, but you also have your own IT experts within STEM who will be able to support you with this. Now, I've put on the bottom here cloud-based services. So if you opt for a cloud-based service, which you really shouldn't, it's not in compliance with OU IT security, but we're well aware that many researchers do use these services because they're easy to access and they're easy to collaborate on. So if you do opt for them, make sure that you're aware of the terms and conditions. So where will the data be kept? That's particularly important if you're working with personal data, as personal data should not be kept outside of the EU in order to comply with GDPR. What's the backup policy for those cloud-based services? What happens if the system fails? When using cloud-based services not supported or licensed for OU corporate use, the accountability rests with the individual choosing to use this method of storage. So if something goes wrong, it's down to you to sort it out. It is against OU information security policy to store OU information on unsupported or unlicensed cloud-based storage. So you really should be checking with the IT help desk first before you do this, if it's really the only option that you have. Now, we have information on all of these systems on a comparison guide, which is linked to on this slide, and I will be sharing the slides with you after this session. So if you'd really like to delve a bit deeper into which storage solution works best for you, that comparison guide is a really good place to look. Now, organizing your data and thinking about filing. So filing is more than saving files. It's making sure you can find them later in your project. So think about the names and formats of your documents before clicking save. Do the name and location make sense? And considering this at the beginning of your project makes it so much easier to find files and related documents later. This helps to keep your data safe and accessible to yourself and to others. File naming. So deciding on file naming convention at the outset of your project is really important because it means that you will keep consistency throughout your project and be able to find things when you need them. So in terms of choosing a vocabulary, it's important to choose a standard vocabulary for file names so that everyone uses a common language. So for example, if I was sharing files in a team, for a presentation, I might put the word declutter your data slides as I have done for this document that I'm sharing here. So I might use the word slides. My colleague Megan might use the word presentation. I might have another colleague who uses the word PowerPoint. So that's 3 terms just to say the word slides. So really think carefully about which words you're going to use and have a standard vocabulary that everyone's agreeing with. In terms of punctuation, it's a similar thing. So you need to decide on your conventions for if and when to use punctuation, symbols, capitals, hyphens, and spaces right at the beginning of your project so that you don't get in a muddle later on. Dates, top tip is to go year, month, day, because that will put your files into chronological order in your folder. And then order. In terms of order, I mean the order of words in your file names. So is it going to be date title, file type, or will it be file type, date, title, for example? In terms of numbers, you should specify in your naming convention how many numbers, how many digits you'll be using in your numbering so that files are listed numerically. So if you have hundreds of files, you'll probably want to start off at 001 so that they will go in numerical order up to 999, if you see what I mean. And then version information. So think about how you're going to version your files. And I'm going to talk a bit about that more in a moment. So ideally, you should be able to tell what's in a file before opening it. And a top tip from me is to create a Readme file right at the beginning of your project if you're working with a team or even just on your own that details the naming scheme so that everyone's clear on how they should be naming files and which vocabulary you'll be using. And here's an example from our team, one that we use in the library research support team. So here's this word slides again. So we use the word slides. The general area of work or topic is RDM. The specific area of work or title is working with research data. And the date, which is in year-month format, is 2021-01. And you'll see that all of the terms in this title have been separated with a hyphen. So that's how we in our team have decided to name our files. Here are some things that you ought to avoid naming your files. So my paper, 20th of June, important, and my absolute favorite is article _ manuscript October _ final version 2 last version, I promise. So yeah, really think about how you're going to be naming things, because having all these finals in your files really is not helpful. Now, thinking about version control, as mentioned before. So good version control helps you to keep track of your data or project over time, space, and different users. So this is really important, especially if you're working in a big team. It ensures that everyone's working from the same version. So making sure that you're not accidentally using an old version, which is now obsolete. It prevents accidental overwriting of colleagues' work. And it allows you to revert to previous versions if you make an edit and later change your mind or spot an error.
Yeah, we can. Shall I try?
Slide's not moving on, sorry.
Does that work? Oh.
Can you still hear me? Something's gone wrong with the slide. Yeah, if you can. No. Has it worked for you? Right, let me try going backwards. Okay, I can go backwards. Can I go forwards? No, isn't that strange? I'll try stopping sharing and sharing again.
Version control, it's useful to keep track of what has changed.
Sorry everyone, this presentation has been fraught with
slide
things
18
going wrong.
that
Okay,
was.
I can't see the slide now, but I can see that it's moved on. Can you see what the slide says? Okay. Let me try and go back to it. Sorry everyone. Okay, so here we go. Oh,
Hi everyone, sorry, Isabel's computer has switched itself off, so we're having a few technical difficulties. Just bear with us a couple of minutes. Sorry about this. Hi, Isabel is just switching her computer back on. I do have her notes here, so if you like, I'm happy to go through them, the slides until she comes back. Just let me know what you prefer. Yeah. Okay, so can everyone see slide 18? I think that's where we got to. Okay, so version control. So it's useful to keep track of what was changed, who by, when, and why. Version control is automatically activated within lots of software. However, if you are manually in control of your code, draft or results, then you should manage the versioning carefully. So even where version control is automatic, it can still be useful to add version control, a version control table to the front of the document or file wherever possible, as this will just ensure that a clear audit trail exists for tracking the development of a data file and in identifying earlier versions when needed. In SharePoint, you might have access to every earlier version of a file, but without knowing what particular changes were made or why, you can find yourself trawling through multiple versions to find what you're looking for. And that's just unhelpful. Okay. It is easier to maintain a manageable number of versions with a clear naming structure. So when versioning files, it is common practice to use consecutive numbering for major version changes, with decimals for minor changes. So for example, as an example on the screen there, V1, V1.1, etc. Be sure to record every change, irrespective of how minor that change might be. But do keep in mind that having too many similar or related files might be quite confusing, both to you and to anyone else wanting to access or use your data. You might think that you know which data file is which, but that may not always be the case as time passes and the number of different file versions grow. It's much easier to maintain a manageable number of versions with a clear naming structure, as long as the original raw or definitive copy is retained and processing is well documented. Intermediate working files can be discarded or at least stored in a separate folder, and I think Isabel will cover this more later, but I'll leave it there.
Thank you, Megan. Thank you for taking over. Sorry, everyone. Just having a bad day. Right. So here's an example of a folder structure. If you have a look at this link on this slide when we send the slides out, this is a really helpful website to look at, and it's got some really good examples of how you can structure your folders for research projects. So essentially, I think the important thing here is not to create names which are meaningless or only mean something to you. Don't create names that are excessively long or relate to individuals, because this can encourage people to dump all their data in an unstructured mess. So if you just have a folder that's called Megan, she might just pop everything in there that belongs to her, and it will be called things like my file, my work, this is the final version, etc. So however you choose to arrange your files, create an index file, so that would be a Word or a text document that you keep with the files, and really explains what the structure of your folders is, so that anyone going in can really understand how to use it. It'll only take you a few minutes, but it can save you absolutely hours of searching later. You can update this as your research develops. Just make sure that if you reorganize your files, that the index is also updated. It can be really helpful to separate current and completed work or versions of files in your folders. So where a document will have many versions or multiple contributors, consider having a current version folder within your folder structure, so that everyone knows which one they should be working from. And review what you have. So don't keep pointless multiple copies of data. Consider carefully what you need to retain for how long, and what can or can't be destroyed or deleted at any point during your project. So you might not have to keep every single file for the entire duration of your project. You might be able to delete things as you go along. So consider this at intervals and at the end of your project. Yeah, you can follow the links now if you're good at multitasking. Thank you for that. So most people think about metadata. So this section is on metadata. Most people think about metadata without even really thinking about it. So if you think about your music collection, I mean, when I first wrote these slides, I was thinking about CDs, but I guess it's all on Spotify now, but it's kind of the same thing. So music collections tend to be organised by artists. They might be organised by title. You might organise your CDs or your records by colour, even. And actually organising things like this is made much easier in a digital environment because you are able to assign different keywords to the same file. So what's really important regarding metadata in research data terms is thinking about what information is needed for your research data to be read and interpreted in the future. What types of documentation will accompany the data to help secondary users and yourself to understand and reuse that data? You should at least include basic details that will help people to find the data. And those basic details might include who created or contributed to the data, the title of the data, the date of creation, and under what conditions it can be accessed. So that might be some kind of license. But it's also usually quite helpful to include details on the methodology used to collect that data. Any analytical or procedural information about how the data is being processed. And then definitions of variables, vocabularies, units of measurement, and any assumptions made, and the format and file type of the data. So basically just a really succinct package around each data item and around the project as a whole to describe what the data is, how it was collected, when it was collected, how it can be reused, and anything that's been done processing-wise to the data so that everyone can understand where that data's come from, essentially. So metadata can be collected at project level, as I just mentioned. So this might be an accompanying material or file that detail the project information. It might be, for example, a Readme file that talks about the project. Or it can be at the object level. And object level metadata is quite often embedded into files. It will be metadata about each individual project. So it might be within the document properties of a Microsoft file, or it might be a header at the top of your files that talks about how the data was created. And you also might have supporting documentation. So that could be things like working papers, lab notebooks, questionnaire or interview guides, could be a final project report. So yeah, it's really good practice, especially if you're sharing your research data, to create a Readme file that contains all this important project level information. And if you're using Ordo, which is our research data repository, we really recommend that you include a Readme file alongside any data that you deposit in there. So make sure it's structured in a way that makes it really easy to understand, because you might not always be there to explain how your data was collected and how it can be used in the future. Basically, I would say anything that will help others to understand your data is useful. Okay. Now, that's all of my top tips in this presentation. So I'm just going to quickly give you an overview of how we can help you with research data management, and then we'll have a bit of time for questions if anyone has them. So we can check data management plans. If you would like your data management plan to be reviewed, please send them well in advance of bid submission, preferably at least a week ahead. But we know that sometimes these things sneak up on you. So if you do tell us that it's urgent, we can sometimes do them a bit quicker than that. So later is better than never. We're really happy to meet with PIs and project teams at the beginning of projects. We can set up bespoke training sessions around your projects, which really look at your data type and your project. We can give you advice on how to prepare your data for sharing, and we provide the data repository Ordo if you need to use that. We have all our online guidance on our website, which hopefully is really useful, and that gets updated very regularly. And also you can just send any inquiries that you have, any general inquiries, to this link at the bottom of the page. So library-research-support@open.ac.uk. That's the place to send inquiries or data management plans if you'd like them to be checked. And here are some useful links. I'm not going to go through all of these now because I realise we're running late on time, but these will be obviously in the slides when we send them out. So please have a look at those. And here is a link for a survey, which I'm going to leave up on the screen. If you could please click on that link and tell us one thing you liked and one thing you would change. And while you're doing that, I will answer any questions you have. Okay, what data management systems do you offer at the OU? Do you have Atlas TI, for example? Okay, good question. This is really something you need to look in the IT catalogue for, because I don't know whether we have Atlas or not. Someone else on this webinar might be able to answer that question for you, but I don't know, I'm afraid. But we do have NVivo and SPSS. So I'm really sorry that I don't know the answer to that question. Worth looking in the IT catalogue. Yeah, GitHub is really good if you're working in computing especially, and there's loads of people at the OU who use GitHub. And what's really nice about GitHub actually is that it has a plugin to Ordo, so you're able to just swing your stuff straight across from GitHub into Ordo without having to do any uploading. So it's a really good system to use. Where is the IT catalogue? Megan, can you find the link for that and put it in the chat? Thank you. You're welcome. If you need any help with that GitHub integration, then let me know. I think we've actually got a blog post about it. Are there any other questions? No, GitHub is an open source repository for it's really for software. So if you're a developer, you would tend to use it to store your software during your project and then to share it with other developers when it's completed. How best to record metadata? It really depends on what kind of metadata we're thinking about. So either embedding it into your files if it's object level metadata. So thinking about each individual file needs its own metadata to describe what it is, or having a Readme file, which we actually have a template for on Ordo that I can share with you if that's useful, which you would store alongside your files in a repository to enable people to understand at project level what everything is. You're really welcome. Thank you for coming, and I'm really sorry about both the technical and personal issues today. It's been a difficult morning. I think this is a related question. You can use online surveys.ac.uk. So you need to get in touch with the surveys team, and they will set you up with a username and password. Everyone who works at the OU can use it, so you shouldn't have a problem. If you need the link or the email address